This is another problem which has appeared in IIT JEE main. As you might have seen from my previous videos that whatever video I am making and posting on YouTube has something to some skill that the student can learn from the video. So each video will try to explain some concept which will be of use in other problems as well. So that is the idea is not to just give solution for a problem, but develop some basic approach that will be helpful in solving other problems too. So this particular problem on magnetic field on the axis of a long wire of a semicircular ring cross section, there are maybe one or two videos posted on the same problem by other authors, but I think whatever I am explaining is slightly different and makes it more clear. So you can just watch this and also watch other audios and other videos, and you can leave your comments about how you feel about this explanation. And if you like this explanation, you please subscribe to the channel so that you will be notified whenever a new video is posted on the YouTube. So here the problem is this is a wire, very long wire, which is I have taken it to be going along. It is going along Z. For example, this is Z axis. This is the wire is this is the direction of the current, and this what we have shown here is the semicircular ring. This is a ring. So we can take a small strip of this wire of cross section d theta. So the current which is going through that is di, is nothing but now the current which is going in this total semicircular ring, the I, that is a current per unit radian, is pi into d theta, gives us the current which is going through the strip which is there in the angle d theta. So this is the current which is flowing. So we know that the current due to a wire at a distance r, suppose if this is a radius, is let us say this is dB, because we are taking only part of the wire, is mu 0 I, which is in this case is I by pi, and d theta then by 2 pi r. This is for the small strip. Now we can just see that for example, if we take a strip which is at an angle 45 degrees, so this vector, we know the direction of the magnetic field, the Bayes-Savart law, is the direction of the current cross R. Yeah. So direction of the current cross R, in this case the direction of the current is Z cross R. Now if I take 45-degree angle, the vector here is, we can say this is minus I. This we are taking it as X, and this is minus X. So the semicircular ring is in the XY plane. So this vector, let us say, is R1, and this vector is R2, which we are taking here as 45. This we take as 45. Then R1, for example, will be, so this for Z, I will write the unit vector K into R1 is nothing but this is minus I plus J. There is a vector R1. So this will give us Ki is minus J. Then Kj is minus I. Okay, then we take the I cross R2. that is another strip which is on the other side of the y-axis. So that we will get is k r2 is, this is, we have I and j both are plus, so I plus j. So this will give us k cross I is minus j, k cross I, sorry, plus j, k cross I is plus j, then k cross j is, k cross I is I j k, k I is j, and we have ki is j and kj is minus I. So we can see if we take one strip on this side and another strip on the other side, we will find one gives us minus j, other gives us plus j, so they cancel. So the only component that remains is the component in this direction, and that component, now for example, if you take this to be, so this is the direction of the magnetic field here, and the direction of the, that is, we can see here it is minus j minus I, so both minus. Now this is plus j minus I, so it will be going in this direction. This one will go in this direction. I'll just change the color. So this will have in this direction. So that will give us plus j and minus I. So they will cancel. So this angle, if this is theta, this is 90 minus theta. So the component of this along minus x is sine theta. So what we get is the, this one dB, 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 the component along the x direction becomes mu 0 I d theta by 2 pi square r. Now this, when now the component is sine theta, because 90 minus theta cos theta, this component here, this is 90 minus theta, so the component of this is sine theta. So when we integrate this, what we get, when we integrate this expression, integral dbx is equal to b is equal to mu 0 I by 2 pi square r. This is sine theta d theta. This is 0 to pi. So this integral will be, this will be 2. So the 2 will cancel. So we will get the answer mu 0 I by, sorry, mu 0 I by pi square r. So this is the answer which you get. So this here, what I would like you to look for is this type of explanation which I have given to identify what are the components of the magnetic field and how they cancel. So I thought this skill, this technique of using this approach would help you in solving other problems. Here I am not trying to talk about right hand rule and all, because that is very abstract and difficult to visualize. So this way one can solve the problem. Hope this helps you.